coherent scattering. So, coherent scattering is also known as the unmodified, classical, or elastic scattering. So, one of the three forms of photon interaction which occurs when the energy of the X-ray or gamma photon is small in relation to the ionization energy of the atom. So, it usually occurs at low energy, usually below 10 keV. So, coherent scattering does not usually occur in diagnostic range, but in rare instances, it does, and when it does, it's only contribute to damage noise. So, these are the examples. So, next is
good day everyone. My name is Jonabel Narbodo from BSRT 2A, and today we will talk about Compton scattering. The Compton scattering, when the X-ray photon enters an atom in the body, and the X-ray photon energy partially absorbs by a loosely bound outer shell electron. This results in the electron being knocked out by its own orbit, which we called ionization. The rest of the electron immediately exits an atom, and that's why we called it scattered radiation. So that's all, guys. Thank you. And next is
So, photoelectric effect is when light shines on a metal. Electrons can be ejected from the surface of the metal. Photoelectric effect is a phenomenon in which electrically charged particles are released from or within a material when it absorbs electromagnetic radiation. The effect is often defined as the ejection of electrons from a metal plate when light falls on it. In a broader definition, the radiant energy may be infrared, visible, or ultraviolet lights, X-ray, or gamma rays. The material may be a solid, liquid, or gas, and the released particles may be ions, as well as electrons. The phenomenon was fundamentally significant in the development of the modern physics because of the puzzling questions it raised about the nature of light, particle versus wave-like behavior that were finally resolved by Albert Einstein in 1905. Examples will be shown in the next slide.
Photodisintegration. So photodisintegration is when an X-ray photon possesses of a minimum 10 megaelectron-volt of energy can interact directly with the nucleus of an atom, causing a state of excitement within the nucleus followed by an emission of a nuclear fragment. So this type of interaction will most likely occur during a nuclear bomb, or when there is an explosion of a nuclear bomb. And when a human being is exposed of that much radioactive substance in their bodies, they will most likely feel abnormalities within or outside their body, which will be shown on the picture followed.